Hey everyone, welcome to our third video in our series on the reactions of chapter 9. So in the very last video, we talked about acid catalyzed hydration of alkynes. In this video, we're going to be talking about another way to do hydration of alkynes, which is hydroboration-oxidation of alkynes. Okay, so hydroboration, oxidation of alkynes. Okay, so this is very similar to hydroboration oxidation in alkenes. Okay, so remember that hydroboration oxidation in alkenes is anti-Markovnikov. And that's all we really need to know, to be honest. So let's do an example. So in the last video, we started with this molecule, okay? And whenever we put it through acid catalyzed hydration, we got a ketone. In this case, we're going to get an aldehyde, all right? So for hydroboration, our reagents are Sia2BH. I'll explain that in a second, with THF. And then a second step, which is going to look familiar to us, is H2O2 with NaOH. Okay, so what this is going to do is it's going to add an alcohol to the less substituted carbon. So it's going to add an alcohol to this carbon on the right because the hydrogen is going to go where there's less hydrogens because it's anti-Markovnikov, right? Markovnikov means that I would put the hydrogen where there's more hydrogens. In this case, it's anti, so it's going to be the opposite. So I would put the hydrogen on the left, and that means I'm going to put my carbonyl group on the right side, all right? So that means I'm going to get this, all right? I originally put an alcohol, which does a ketoene altotomerization into a carbonyl. Okay, whatever. Ketoene altotomerization, I talked about it in the last video. Okay, so if you're curious about that, then that's there. Okay, so let me talk a little bit about Sia2BH and what that means. So Sia, okay, is a abbreviation of sec isoamyl, okay, which sec isoamyl is this group. So it has something attached to it, but sec isoamyl is 1, 2, 3, 4, 5 carbon. These 5 carbons here. Okay, so this is a sec isoamyl group, which can be abbreviated to siamyl. Okay, siamyl. So Sia2 means that I have 2 of those groups on a BH. So BH, and then I just have 2 of these groups on there. So that's 1, and then this is 2. So this is a di-sec isoamyl borane. Okay, so Sia2BH. All right. Okay, so that's what that is, just so we can make that clear. All right, so in the last video, whenever we were doing these reactions, I was typically making a ketone. In this case, I'm going to be making an aldehyde whenever possible. All right. So let's do another example here. Let's do this one. And again, my reagents are always going to be the same, Sia2BH with THF typically. And then as a second thing, I'm going to be using H2O2 with NaOH. All right. So again, I'm going to be adding the carbonyl group on the right side because that's the less substituted carbon, right? So I got 1, 2, 3, 4 carbons. So 1, 2, 3, 4. And then I just add my carbonyl group here and I'm done. Okay, so I've made 2 aldehydes so far. All right. So now we've looked at it with terminal alkynes. This is what it's going to do with terminal alkynes. So now let's take a look at an internal alkyne. All right. So in this case, right, this reaction is going to prefer, whenever it can, to make a aldehyde. But you'll see in this case that it's actually not possible to make an aldehyde, all right, because this is an internal alkyne. So that means that this side, the right side, and the left side both have something on them, okay? So that means that no matter what, I'm going to have to make a ketone. All right. So I make this ketone. And just like in the last video, I also make this ketone, right? Well, these are actually the same thing. Okay. These are the same thing. So my only product is this. All right. So with a terminal alkyne, all right, I'm going to make an aldehyde with hydroboration oxidation, and then acid catalyzed hydration of alkynes is going to make a ketone. But whenever it comes to internal alkynes, I can only make ketones with both reactions. Okay, so acid catalyzed and hydroboration are going to do the exact same thing with internal alkynes. All right, they're going to do the exact same thing. So now the only other thing really that we need to look at is a unsymmetrical, because this is symmetrical, right? So let's take a look at an unsymmetrical alkyne. So we'll take a look at this one, all right? And again, I'm going to put this with the same reagents, not a 2, psi a 2. And then with THF. And then H2O2 with NaOH. Okay, so again, this is going to be doing the same thing that it did in this one. The only difference is that I add a ketone on the left side and on the right side. Okay, so I get 2 different ketones here, all right? So 1, 2, 3, 4. So I get this ketone. And then this is 1, 2, 3, 4. So 1, 2, 3, 4. So make sure to count our carbons, make sure we're good. So 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay, so this is one ketone I get, all right? And then the other ketone I get is just this, but on the other carbon. Okay, so I'll put it on that carbon as well. So let's do that. So now I'm putting it here. Whereas the other one was here, I'm putting this one here. All right. So I get 2 different ketones in this case. So regardless of whether I use hydroboration oxidation or I use acid catalyzed hydration, I'm still going to get these 2 ketones with an internal, unsymmetrical internal alkyne. Okay. So the only time hydroboration and acid catalyzed are different is whenever I have a terminal alkyne, like these first 2. All right. So I make aldehydes in this case, whereas with acid catalyzed, I would make ketones. All right. And as far as the mechanism goes, we're not going to worry about the mechanism. Okay. So this is basically all that we need to know for this reaction. So hopefully this video was helpful. This is the last type of hydration, so we're not going to be worrying about any other types of hydration. So in the next video, we're going to be working on something different. So I appreciate you watching this video, and I will hopefully see you in the next one.